গবেষণা করা নয়, ক্যাপাসিটি বিল্ডিং এবং ক্লিনিক্যাল রিসার্চ এই দুটো সবসময় একসঙ্গে চলে। তো আমি ওরেশনটা ইংরেজিতেই দেব, কিন্তু আরেকবার আপনাদের সবাইকে ধন্যবাদ জানিয়ে বলি যে আমি এই টপিকটা চুজ করেছি কারণ এই আর্টিফিশিয়াল ইন্টেলিজেন্স নিয়ে প্রথম আমি কিছু কিছু কাজ করেছি, আর স্টেম সেলটা কোনোটাই সার্চ, সেখানে কোনো রিসার্চ নেই। তো এই ছবিটা কেউ আগে কখনো দেখেছে? তাহলে বলি আপনি দেখেন, কারণ আজকে দুপুরবেলা এই চ্যাট জিপিটির কথা হচ্ছিল, আমি চ্যাট জিপিটিকে বললাম যে একটা গাধা যদি এআই শেখায় ডাক্তারদের তাহলে ছবিটা কিরকম হবে তুমি আঁকো, এবং ও কিন্তু এটা এঁকেছে, এটা মেশিনের দ্বারা অঙ্কিত এবং এটা জেনারেট হচ্ছে দুপুর 1টার সময়। ওই যখন ছোট করে তলা এখানে একটা বি লেখা আছে, তার মানে বিল, মানে বেসিক্যালি চ্যাট জিপিটিকে টাকা ঢালছে মাইক্রোসফট গুগলের সঙ্গে লড়ার জন্য। সুতরাং এই ছবি আপনি দেখতে পারেন না, কারণ এটা এক্সিস্টই করে। তো আর্টিফিশিয়াল ইন্টেলিজেন্স যদি এরকম ছবি আঁকতে পারে তাহলে ভাবুন, এই যে মাঝে মাঝে জার্নালরা বলে না এই ছবি চলবে না, এটা অমুক জায়গায় আছে, তো এর তো কোনো কপিরাইট নেই, কারণ মেশিন তো কোনো কপিরাইট চাইবে না, তাই না? তো এইটা হচ্ছে মেশিন কি বুঝেছে, আপনাদের সঙ্গে আমি কি ডিসকাস করব। যাই হোক, what we will discuss today is what is artificial intelligence. Artificial intelligence has been there in healthcare for almost 30 years. We sometimes realize we don't. I'll give you some examples, and then for a general audience I'll tell you what stem cell transplant is, especially for that allogeneic hematopoietic stem cell transplant is. What are the challenges, especially from the data point of view? From the hematologist point of view, there are multiple challenges, but from a data scientist point of view, who will actually feed into artificial intelligence, there are a lot of challenges. And then I will show you some experiments which have been done with AI. I will show you a particular study which has been conducted in this country from Manipal Institute of Technology, but all the authors are engineers, but the publication is on stem cell transplant. And then obviously what can be the way forward. So what is AI? Artificial means it's a copy, right? So it's basically a copy of human intelligence, which we have not achieved till now. It aims at reproducing the human brain's functions. Like if I told an artist to draw something, the artist could have drawn using his or her cognitive function. AI can do it now. And AI is the capacity given by humans. Remember this. We have given this capability to machines so that they can memorize, and that they can do better than us, we have already seen. They can learn from experience. They can think and create. Now this is the most controversial issue, but obviously I will not go into the ethics and all those things. They can speak, so they are speaking, not only through Siri, Alexa or others, through numerous chatbots, and they can judge and make decisions. Like if you have a dialogue with a patient and you give the clinical picture and you ask what could be a best way of treating, AI has the capability to give you a suggestion, but you are the decision maker. So if you look at the entire domain, there is neuromorphic computing. Elon Musk's Neuralink has already got an FDA approval for clinical trial that they will put in a chip into the human brain, and paraplegics will be able to move their limbs. Basic systems are autonomous, machine learning, deep learning, neural networks, pattern recognition. But let me share one thing. Suppose you have to teach a machine to distinguish between the face of a dog and a human. The minimum number of pictures required are at least 1 million. But if you want to teach a 6-month baby to distinguish between a dog and a human, it needs only 2 images. So that is what natural intelligence is, and that is what artificial intelligence is. So surprised to know that in 2016, the accuracy of a chatbot in understanding human voice, human communication is more accurate than a human. Similarly, for image recognition, by 2017, the capability of discerning an image has surpassed the human capability. So, but you will not be afraid of that, because I told you the amount of information you have to feed, and then there are certain other challenges which I will share with you. So in 2023, the top 10 artificial intelligence trends, we have heard of ChatGPT, large language models, but there are other things which are going on. Significant development in predictive analytics. Whatever you do, suppose you are driving a car, and based on your past performance, what is your chance of causing an accident if you are driving at Kolkata? That can be predicted. ChatGPT is a form of generative AI which is based on large language models. I will show you some work we have done using that same OpenAI model. Information security, because that is very important. Who has access to what kind of information, and so that hackers cannot hack it, and also fake news can be detected. Right? Launch of better autonomous systems, like needing minimal or no human intervention. Art through NFTs. So, non-functioning tokens. Because artists are losing their copyright, it is there everywhere. So these are some of the things which are going on. You must have seen digital avatars, and right now, if I am speaking here, technology is available that my digital avatar can deliver the same speech in real time, in Japanese, in my accent, and with my gestures. That is possible. Artificial intelligence ethics is a very sensitive issue. We have to decide on it. But artificial intelligence can kill all of us, not by taking our jobs, but by developing military weapons today, where the drones and others can go and fight the war. They can kill humans, humans can't kill them. So that is also a concern. Process discovery of how a product or service can be developed, and embedded applications which are already there, in your smartwatches, in your phones, in your microphones and others. Now, if you ask me that why we should embrace artificial intelligence and not try to stop it, because if you try to stop it, the markets will not allow it anyway. Because the fundamental thing is machines can see what the eyes can't. You may become fatigued. You have limited time, limited observation. But when 100 million heads and their information and their thinking goes into a system, they can see something which you as an individual can't. So what about healthcare? Let me come to healthcare, and I think these 6 characters have changed healthcare. So APGC is known to all of you. 0 and 1 has brought in the digital revolution, and we are slowly moving from disease diagnosis to management to prediction of outcomes, which is my topic today, and then to prevention. So obviously prevention is better than cure. Now before I go to AI in healthcare proper, let me introduce a concept which already exists and which is being implemented. That is not a digital avatar, we call it a digital twin. Now if someone is residing in the remotest part of Sundarbans, not being able to travel to my OP clinic in medical college, I can always have a digital twin of that person in front of me. How? It's a real-time digital counterpart of a physical object or a process. And how can it be done? It can be done by, the patient's height, weight, blood pressure, other things which we call spatial digital twin. Temporal digital twin means the entire journey of the patient till now. What happened when the patient was prescribed, say, cilnidipine or amlodipine or say a beta blocker? What happened to the blood pressure? What happened to the kidneys? Molecular digital twin of the patient. That means whatever genetic data we have, what are the polymorphisms, what are the mutations this patient has, and then, a professor who has 30 years experience in a medical college and an intern, their thought process would be different, their beliefs also would be different, because as we grow grey hairs, our rationalization, our visualization changes. These can be transferred from the professor to the intern through some knowledge pathways, and physician reasoning digital twin. So, we have a different way of reasoning. We follow a Bayesian algorithm which we are not aware of sometimes, that whenever we are asking a particular question in history taking, we are trying to weigh what the possibilities are in this patient. So patient digital twins, we have published something way back, as you can see here. This has been one of the most cited papers where we showed by looking at thermal entropy and molecular data, the chances of development of cancer can be predicted through DNA dosage and others. Now, those are, you can say, in the basic science, basic research domain. But, antibiotic resistance will kill more patients possibly than cancer in the near future. So, we showed that we can use certain probabilistic and deterministic knowledge graphs. It's similar to what we do in our human brain, that you think of this, okay, should I proceed in this way or that way? If I proceed in this way, what will be the outcome? So, that can be plotted in form of a graph. We have used different forms of graph like G4 and others. And this we published, and what I want you to see here is, along with me, the other authors are also engineers. So basically, if UGC has now told that engineering has to be taught in medical colleges, and medical colleges should also teach engineering, you will understand why this has been, some feel it's a draconian measure. But anyway, I firmly believe, not only I, my colleagues, that AI means not artificial intelligence, it is augmented intelligence. That means on top of your natural intelligence, sometimes you might not recall something. We have so many biases. When you are seeing a patient, and maybe the last 10 patients you have seen, they actually influence your decision to diagnose that. Machines, fortunately, do not have that kind of bias. But they can be made into actionable insight because you can get so many inputs. For follow-up, especially in stem cell transplant, the patient might go away back to his home. How do you monitor him or her? So you will get the data from the watch or maybe certain other devices, wearables, from a smartphone. Smartphones are becoming cheaper, data is becoming cheaper. If the local clinic is using a tablet or something, or if they are approaching or say accessing the internet. Nowadays, most of the people access internet through their mobiles, not through their desktops or tablets, right? All can come together. You can use blockchain technology, you might not use it also, but they come into a web. API is basically the kernel of which it interacts, and artificial intelligence will get information from where? From all the sources from we get it. So, PubMed or Panther or Open Foundry, electronic health records, electronic medical records, and then there are already available reasoning networks which are open access and free. So, you can develop certain unknown knowledge which the human brain could not interpret till that point of time. I'll give you examples. And then this goes to reasoning network, and as I was telling you, we are using Neo4j graphs, belief network based on the biomedical, clinical, therapeutic knowledge, and then you get some information which was not known to us earlier. So, if you think that this is very futuristic, let me tell you that this is not, and I will show you some examples. So this we have published, we call it diseaseomics. and we have published in Cross Digital Health last year. It was with the reviewers for almost 1.5 years in 2022, where we have shown that if you build in the disease ontology, there is this ICD system, ICD-10, but it's not good. Now we have ICD-11. You also have other nomenclatures. You give the disease-based gene knowledge, you give the pharmacogenomic knowledge, and custom annotations for your electronic health records, which we sometimes are very reluctant to use. But if there is no data, there can be no big data, there can be no artificial intelligence. So comorbidity knowledge, disease trajectory knowledge, cancer trajectory knowledge, natural history of the disease knowledge in your country, in your state. So these can all come with a thematic integration, a semantic integration, and an intern who is being forced by bondage to work in a village where there are certain diseases which were not taught in the classes. By just clicking in the symptoms, this system will help them to manage the patients. So as I was telling you, other than ICD-10, 11, you have SNOMED, UMLS and others. Basically, let me tell you, a computer does not understand the difference between hypertension, blood pressure or high blood pressure. So you have to use certain codes. If you go to a very sophisticated hospital today, you'll see the physician is writing and then they are scanning it. So I call it human readable, sometimes not even human readable because the handwriting is so bad. So human readable, sometimes human understandable, not machine readable, not machine understandable. Then you will not be able to get the help of the machine. The second is, like you have in IHTM, electronic medical records. Here, the machine can read it, but there are problems because we sometimes write complex English sentences. Using natural language processing, we can develop some insight, but still it is not machine understandable. So you need some sort of coding so that the machine understands, and we have used these codes just to show you. And then the machine can actually predict the association. So the machine can predict that a diabetic, when it comes after say 5 years, there is a chance of the creatinine increasing or the vision going down due to diabetic retinopathy. And these are the things which the machine can assess and can help you. So we will never be out of job, right? Don't worry about that. In hematology, we have certain tools which are open access free, which you can all use. There are artificial intelligence models, and the students who are here, I always encourage them, play with them. Maybe you generate some data through your dissertation. Use these models to see if you can generate, because chasing a p-value is nothing. You should never chase a p-value. But statistics has its own limitations, especially non-Bayesian statistics. So artificial intelligence takes care of that. And no discussion on AI can be complete without generative AI or ChatGPT. Now I am just showing you, we use the ChatGPT model to load this book, National Guidelines for Clinical Management of Dengue Fever. This is published by the Ministry of Health, Government of India. And then we told the machine that use table 1 and tell us the requirement of a fluid based on the body weight, and the fluid to be given in 24 hours. It gave a perfect answer. So the thing is, in a stem cell transplant unit, you as a hematologist is not the only person. The more important persons are the nurses, the pharmacists, the housekeeping, and even the food and beverage persons. So if you have guidance so that every point of time you have a checklist so that they can tick they have done it, and the machine can point out if there are certain near misses or errors, then the outcome can be better. This is just one example because this is what ChatGPT is capable of. Now those of you who do not know what allogeneic hematopoietic stem cell transplant is, in short what we do is, say I will take the example of blood cancer. You have given chemotherapy now you want to consolidate it, or maybe there has been a relapse and you have to want to kill the leukemic stem cells. So you give high-dose chemotherapy, but you also want what is called graft versus leukemia effect. That is the donor versus leukemia effect. So you take a donor who has a match. It might be HA, full match, haploidentical, anything. You collect stem cells from that person. You prepare the recipient's immune system, just like we prepare the soil for planting certain crops. We use chemotherapy there, we are becoming smarter also. And then we infuse the stem cells, just like we did blood, right? And then this immune system is built with the donor cells. So when we prepare the soil, we call it conditioning. When the stem cells start working, we call it engraftment. When the immune system is rebuilt, it is called immune recovery. And this is a critical period for two things, infections and GVHD. So graft versus host diseases, we have an immune system which will not tolerate outside foreign cells. But the grafts who come in, they also face foreign cells in the recipient's system. This actually helps us in the form of graft versus leukemia or lymphoma effect, but it can cause havoc because it can destroy the liver, the lungs, the skin, the